Hey everybody, Mr. Adamson here. Welcome to another lesson in Science 14. This is again part of Unit 2, and we're going to talk about today simple machines. So what is a simple machine? A simple machine is a non-powered mechanical device that changes the direction or magnitude of a force. So in general, they can be defined as the simplest mechanism that uses mechanical advantage, so also leverage to multiply a force. Usually the term refers to 6 classical simple machines, which are defined by Renaissance scientists. So we have a lever, we have the wheel and axle, we have a pulley, we have an inclined plane, and we have the wedge and screw. So these are all examples of simple machines right here. And simple machines, for the most part, transfer energy. So first one, starting out, we're going to talk about is a lever. And levers are bars that pivot on a fulcrum. So if we just go back a picture here, see we have a picture of our lever, and there's the fulcrum. So that's the point that it's going to pivot on. So it's either going to be going down, so the force is going to be pushing down, and the load is going to be going up. So the object the lever moves in the load, and the force required to move the object is the effort. Now the distance from the fulcrum to the load is the load distance. So going back, so the distance from the load to the fulcrum here, so right in between is the load distance. And the distance from the fulcrum to the effort is the effort distance. So from the fulcrum here and the force being pushed down or the effort being pushed down, this is the effort distance in between here. Now there are 3 types of specific levers we're going to talk about. The first one is first class levers, and the fulcrum now for a first class lever is between the load and the effort. So we look at this picture here, the fulcrum is between the effort and the load. It's a really good example of when you have to move something with a crowbar, or this guy's trying to move a rock out of the way. You can see the fulcrum is the smaller rock, the lever is the big stick, the effort is the man himself, and the load is the rock they're trying to move. Another great example of everyday use is a pair of scissors. The fulcrum's in the middle, it connects the 2 parts of the scissors. The force you apply is on the one part of the scissor, and the sharp edge of the scissor cuts up. A second class lever. The fulcrum is at one end, effort's at the other, and the load is in between. So the fulcrum's at one end, the effort's at the other, and the load here is in between. So a really great example of that we see in everyday life is a wheelbarrow. So the fulcrum being the wheel, the load in the middle of the barrel part, and the effort lifting up the handles. If you look at nutcrackers, the fulcrum's at the end, the load would be the nuts in between, and the effort squeezing the 2 parts together. Or another great one is a door, of a car door, or any door. The load is the hinge, or the fulcrum is the hinges, the load itself is the door, and the effort's pulling it open or shutting it. A third class lever, the fulcrum is at one end, the load is at the other, and the effort is in the middle. So again, the fulcrum's at one end, but the effort and the load are switching places from like in a second class lever. So in a third, the effort's in the middle, and the load's at the other. So a great example of this is sports equipment. We look at a bat, the fulcrum is right here at the end with the player's wrists. The effort is swinging the bat through, and the load's going to be on the end of swinging the bat's weight. Tennis racket, fulcrum right here where you pivot in the hand and the wrist. The effort's right there on the handle, and the load is the weight of the tennis racket. We look at tweezers. We have tweezers that are connected together at one end, that's the fulcrum. You're picking up something in the other end or pulling something out, that's the load, and the effort squeezing the tweezers together. Staple remover, load pulling out the staple, fulcrum the hinge at the end, and the effort's pushing the staple together. Now your body has levers too. So we have 2 different examples here. So if we look at this example here, many of the muscles and bones in your body work as levers. And the third class lever shown here, the bicep muscle, so the muscle right here in your bicep, provides the effort force. The tendon itself occurs where the effort itself occurs where the tendon meets the bone, so this little white part right here. And the hand is lifting a load up. So that's a third class lever. If we look at this over here, figure 7.17b, in the first class lever shown here, the tricep muscle provides the effort force. So the tricep muscle in the back of your upper arm. The effort itself occurs behind the elbow, where the elbow and the tendon meet, and the hand is pulling down. So there's the load, the fulcrum, and the effort of the muscle. Now, a couple things to think about when we're dealing with simple machines. We got to think about what distant multipliers. Now, distance multipliers, these move loads through a large distance, but require a short distance effort. So this is an example of this would be third class levers such as sports class levers, axes, and hammers. So hockey stick's a great one of this. The hockey stick moves a load through a large distance, but requires a short distance of effort. So you're going to shoot a hockey puck really far, but you don't actually have to swing the stick that far. And force multipliers. Force multipliers, these are simple machines that can move a large load. So a small force on the effort end of the lever puts a large force on the load. When the effort end moves a great distance, the load moves a small distance. And first and second class levers are force multipliers. And that's it for this lesson about simple machines and talking about effort. Hope you're able to take something from that. And until next time, have a great day.